This video is part 3 of a 4-part series titled How to Repair Anything Without a Manual. If you haven't watched part 1 and 2, I do recommend you go back and watch those first, as it will put everything into perspective for you and make it easier for you to understand. Okay, so in part 2 we did a variable DC power supply test, and we also did a thermal imaging camera test, and from those two tests we were able to determine that the fault is most likely on this line here, coming down from the relay, this line here. We came to the conclusion that one of the components on this line that sends the signal to switch the relay on must be playing up somewhere, or it may possibly be faulty. And what we're going to do today is we're going to follow that line down from here, and we're going to start testing some of these components with the multimeter. And what we're going to do is we're going to compare the readings from the faulty device against the working device, and we should be able to work out where the problem is. So to do that, what I'm going to do is I'm going to introduce you to another new tool, which is the multimeter, and we're going to use that multimeter to try and locate this fault. So let's do that now. Okay, so what is a multimeter? The easiest way for me to explain to you what a multimeter is just to think of it as a measuring device. You put water in a jug, you look on the side of the jug, and you see how much water is in the jug. Well, with a multimeter, what we do is we use it to measure the different properties and states of electricity within a circuit and also within components themselves. Now, when people talk about multimeters, they usually talk about voltage, they talk about current, they talk about resistance, they talk about capacitance, they talk about inductance, they talk about frequency, and so forth. But today I don't want you to focus on any of that. Because this is a beginner series, I'm going to make it very simple for you. Today all I want you to do is find this setting on your multimeter. This setting here. On cheaper multimeters, it's combined into one, so you can see the diode symbol here, and you can also see the symbol for the musical key. And what these two symbols represent is diode mode and continuity mode. And that's all I want you to focus on for today. And what we're going to do is we're going to use this setting here to measure the differences in the readings from the working board to the faulty board. And we're going to work our way down the board. We're going to measure different points on the board, and we're going to compare the readings from the faulty to the working, and that's how we're going to find the fault on our faulty device. So what you do is you get your minus lead or your black lead and you connect it into the COM port, okay, and then what you do is you take your plus lead, right, and you connect it to the port that matches the symbol here. So you can see here the diode mode and the musical keynote symbol are here, and you can see here above this connector here diode mode symbol here. So what you do is you take your plus lead and you plug it in to here, and now you're ready to take your readings. So let's go over to the microscope and let's start taking some readings. Okay, so we've prepared our two devices on the bench, and what we've done is we've put our multimeter into continuity mode. And if you have a look on the top left corner of the screen, you should be able to see the readings from the digital multimeter displayed on the screen. And what we're going to do is we're going to work our way down from the relay, and we're going to just test the different components around the board. And we're going to test on the faulty board, and then we're going to test on the working board. And we're going to compare each component as we work our way down. So let's do that now. Now, for continuity mode and diode mode, what you want to do is you want to take the red lead and you want to connect it to any ground point on the board, and you want to take the black lead and you're going to use the black lead to test the different points on the board. So the red lead should be on ground, and your black lead, you're going to use it to test your components. So let's do that now. So let's test this resistor here at both ends. Okay, we're getting a reading of 620 ohms. This end here, we're getting 522. Let's test this on the faulty board. Here we go, 634. Okay, and then we're getting how much? 534. So that's quite similar. There's no major differences there. Let's test the next component down in that line. Which is around about here. Now we're going to test the pins of our first IC. Okay. Now remember, when you come to ICs, wherever you have a circle, that's usually pin 1. So we can start measuring from pin 1. Let's measure pin 1. 677, 676, 680. Okay, that's quite similar. Pin 2, 677, 675. This is ground. So let's do pin 2, 680, pin 3, 681, and pin 4 is ground. Normally what you'll have is 1, 2, 3, 4, and then pin 5 starts from here, not from here. So 5, 6, 7, 8. So let's do them let's measure these, and we'll go onto the faulty board and we'll measure these. So we've got 6, 7, 6, 7, 7, 1, 2, 5, 1, 9. Okay. So let's go onto the faulty board. 6, 8, 6, 8, 1, 2, 5, 3, 3. Okay. Let's measure that one again. Yeah, so this IC seems fine so far. Okay. Now, what does this follow on to from here? This line comes down here. If you can have a look down here, it goes through these components and it goes into this IC here. So I just measure these two resistors here at the bottom. Oh, look at that. That's a big difference, that is. This is 748 ohms, and this here is 748 ohms and 748 ohms. But if we have a look on the working board, right, those same two resistors, they measure 1363 ohms, and here we go, 1370 ohms. So if you noticed, we just found our first major difference in the readings. Okay, so let's follow this line here and see where it's going. So if you have a look here on the working board, it was about 1300, above 1300 ohms at these 2 points, and on the faulty board it's about 700 ohms at these 2 points. So that's a big major difference in the resistance readings. So what we want to do now is we want to follow this back, these two here, and we want to see where they lead. So if you have a look, this line leads to this IC here, and if you have a look here, this line leads all the way up. Again, it's going back from here into this IC here, and then it goes into this IC here. Now what I want to do is I want to measure the pins on this IC and compare them to the working board, right? Because it looks like the problem is probably coming from this IC here. So let's run some tests and let's find out what's going on. Now remember what I said, wherever you see the circle here on the IC, that usually denotes pin 1, and you're going down this way, 1, 2, 3, 4, 5, 6. Is there another pin there? Yep, 7. You've got 7, 8, and then you'll have 9, 10, 11, 12, 13, 14, 15, 16. So let's measure pin 1 on the faulty IC, right, and let's see what it gives us. Okay, we've got a ground there. Let's measure that on our working IC, and pin 1 is also a ground, so that's fine. Let's measure pin 2. Pin 2 on our faulty IC is also ground, and let's measure pin 2 on our working IC. That's also ground as well. Okay. Now let's measure pin 3, and work our way down. So let's measure pin 3. Here we go, pin number 3, and we're getting 720 ohms, right? Let's measure that on our working IC. Pin number 3, 1, 2, 3, and we're getting over 1200 ohms on our working IC. So straight away, that's telling us that something is not right on this IC. Let's continue to measure the rest of the pins. Right, the faulty one is displaying just above 740 ohms. Let's measure pin 4 on our working IC, and we've got over 1100 ohms. Right, so that's a major difference. If you've got 20 to 30 ohms, even up to 50 ohms difference, that's not something to really be worried about too much. But when you get like a couple of hundred ohms difference, then your multimeter is telling you that there is a problem here, and you need to investigate it further. So let's measure pin 5, right? And we've got 600 ohms on the faulty one. Let's measure pin 5 on our working device, and you can see here. Okay, so this one's the same, 600 and 600. These two pins are the same. Let's measure pin number 6, third one up from the bottom. This here is a ground. Right, pin 6 is ground on the working IC. And what is pin 6 on the faulty IC? 1, 2, 3 is also ground, so that's fine. Let's measure pin 7. That's also ground. And what is pin 8? Pin 8. Okay, so these last 3 pins, they look like they're ground. Let's have a look on the working device. 1, 2, 3. Okay, so that's fine. Those 3 are ground. Let's measure pin number 9 on our faulty device, and it's 662. Let's measure pin number 10, 662, and pin number 11, 9, 10, 11. So 6, 6, and 8. Let's compare that with our working board. Pin number 6 is 6. Pin number 7 is 7, 6, between 6 and 7. And pin number 10 is 8 too. So those 3 pins are quite similar. Nothing really to be worried about. Pin number 12 is 746. Pin number 13 is 746. So let's measure that here now. 9, 10, 11, 12. Oh, look at that. Here we go. That's a big difference. So the other one was about 700 something ohms. And here we've got, in the working IC, we've got above 1300 ohms. Here you go, it's pin number 13. You've got, again, 1300 ohms. And if we go back to pin number 13, here you've got 700 ohms. So there's a massive difference here. Let's measure pin number 14. Here we've got 720. Let's measure pin number 14 on our working IC. And here you've got over 1000 ohms, to over 1200 ohms. Right, so that's a big difference. Let's measure pin number 15, I believe. Pin number 15 is ground, and pin number 16 is 500 ohms, just above 500 ohms. So ground and 500 ohms. Let's compare that to the working one. Right, here we go. Pin number 15 here is ground, and pin number 16 is 500 ohms, just above 500. So those two are similar. So we found quite a few pins on this IC here where the resistance was much lower than the resistance on the working IC on the working board. Right, now what we want to do, because it's not just one pin, there was quite a few pins where we found a few differences here. Now what we want to do is we want to take the identification code of this IC and we want to investigate it further. What is this chip responsible for? Right, so let's do that now. Let's take a note of this, the number on this IC, which I'll do that now. So if you have a look here, the code is 74HC4053D 74H C4053D. Now what I'm going to do is I'm going to show you how to find the data sheets for any IC. If I show you how to do it for one, you should be able to find it for any one. So let's do that now, and let's investigate this chip further. Okay, so to find the datasheet for any given IC on the PCB, all you need is its unique identifier. And what you do is you open up a Google page and you type in the digits that identify the IC. So in this example, it's 74HC4053D. And then as you can see here, you've already got here datasheet. So you type in the unique identifier and then you type in datasheet. Right, so after you press enter, you're going to have quite a few links that will come up here. And generally, if you go to the Mouser Electronics page, they're quite a known brand, and they usually have quite clear datasheets for all the different ICs available. So if we click into this here now, 74HC4053D, it's opening up Adobe Acrobat and a PDF document which gives us more information about this IC. So it says here, functional description, what is this IC? And this is where we find out what its job is. So it says here that this is a triple 2-channel analog multiplexer demultiplexer. So if we go into Google and we ask the question, what is an analog multiplexer? Then you can see here, it says here, multiplexer refers to a type of combinational circuit that accepts multiple inputs of data but provides only a single output. The demultiplexer refers to the type of combinational circuit that accepts just a single input but directs it through multiple outputs. So this chip, in essence, it's a kind of digital switch, right? And that's all we need to understand for now, because that would make perfect sense. Our relay is not switching on, okay? And the IC that is responsible for switching that relay on is most likely this IC here, and I'm going to go with that. What I'm going to now do is I'm going to go on to eBay and I'm going to search for this IC and see if we can find it locally and get it ordered in. And this technique that I'm going to teach you now, you can use it to search for any IC and order them locally. If you can't obviously get them locally, then you may have to order them in from China, but we'll deal with that when we get to it. So let's do that now. Now if we type in this identifier here and we put space and IC next to it, and let's do a search. Okay, so we can see that this IC is quite commonly available, right? So that means this must be something that fails quite a lot. The prices start from $2.89 and they go up to here. You've got one for £1.92, £3.75. So it's within about the £5 range. Okay, so what I'm going to do is I'm going to order one of these ICs and I'm going to proceed to change out that IC, and let's see if that fixes our problem. Right, because these videos are for beginners, I want to keep them short and sweet, and I think that's enough to take in for today. So what I've done is I've ordered that IC, and in part 4 of this series, what I'm going to do is I'm going to introduce you to the soldering iron, I'm going to introduce you to the microscope, and I'm going to introduce you to the heat gun, and we're going to use those 3 tools in combination to replace that IC, and hopefully that should fix our device. Now, these techniques that you learned today with this multimeter, you can use them on just about any device out there, and that is essentially what we do in electronics repair. If we have service manuals, we check the readings from the service manuals against the components, and we find where the faulty components are. And if we don't have a service manual, we take the readings from a working device and we check them against the faulty device. Well, that's it for today, and again, I hope you found this video beneficial. Bye for now, and have a nice day.